Alrighty, ladies. So in the last section of chapter 8, we really bring it all together. So we are going to be following the instructions of factoring completely. So when we factor it completely, it means that we've done all the factoring we can pretty much. So it means that what we're left with is what's called unfactorable polynomials, which just means you can't factor it. So for example, x squared minus 1 would be unfactorable. We like to try to end with just x plus something, or x with no exponent, which is always an invisible one, right? Sometimes we're left with x squared, but we still wouldn't be able to factor x squared plus 1 because it's not dots. We can't take out a GCF, and those were really our only two options when we had two terms. So therefore, if we left it like that, we would be done factoring completely. So when we factor completely, there's always kind of 5 main steps. Well, just like always, we've said that we always take out a GCF, right? So if there's a GCF, take it out. Step 2, you look for a pattern, and we really focused more on difference of two squares this year. Perfect square trinomial is that other pattern where you end with one set of parentheses squared. Don't worry about that though, because we would end up with that if we moved on to step 3, which is factoring like normal. So step 1, GCF. Step 2, dots. Step 3, factor like normal. Sometimes that's going to involve divide and slide, so we'll be on the lookout for that. Step 4, if none of those other ones have worked, then you try to factor by grouping. And then after you're done factoring by grouping, sometimes you're left with dots again. So in order, we first look for a GCF, then we look for dots, then we factor like normal, then we try to factor by grouping, then we try to factor using dots again. And we just go through that process over and over. So in example 1, and I think it's really all example 1 technically. So example 1a, we want to factor completely. So we always start first looking for a GCF. So what can I take out of all 3 of those terms? A 2x. And remember, with GCFs, we don't throw them out the window, we set them aside. 2x cubed divided by 2x, 2's cancel, and you're left with x squared. Plus 16x squared divided by 2x, 16 divided by 2 would give you an 8, x squared divided by x is an x. And then 24x over 2x is just a positive 12. So we tried factoring by taking out the GCF. We were successful, but we should keep going. Now this can't be a dots pattern because that's if you only have a binomial, but we have a trinomial, so we're going to try to factor like normal. That 2x is along for the ride from here on out. We're looking for two numbers that multiply to 12 and add to 8. That's going to be 6 and 2. My signs are the same, they are both positive. So after we factored like normal, we would look for grouping, but we don't need to factor by grouping, and we don't have any dots left. So that is our final answer. In example B, we would first look for a GCF. Well, I don't have one. It's not going to be a dots pattern because it's a trinomial. We have 3 terms. So then we would try to factor like normal. So we would say, okay, set up your parentheses. We're looking for 2 numbers that multiply to 1 and subtract to give us 2. Well, wait a minute. The only numbers that multiply to 1 are 1 and 1. But they don't subtract to 2. They would add to 2. So we are actually not going to be able to factor this. So remember, if you cannot factor, you would write CNF, or sometimes you'll see it as prime. Excuse me. Example C, we first look for a GCF. I don't have one. Then we try to look for dots. Well, there's 4 terms, so it can't be dots. We're not going to be able to factor like normal because there's 4 terms, so that leaves us with factoring by grouping. We break it into the first group and second group. First group, our GCF would be an a squared, and you set it aside to be left with a cubed divided by a squared will give you an a, and then your a squareds cancel in your second part, you're just left with 3. Now in the second set of parentheses, we know we need to be left with an a plus 3 again from our second group. So what do we have to take out of there in order to be left with that? Nothing. Or, remember, you can always technically take out a 1. So then from our two groups, our GCF would be that a plus 3, and we are left with the a squared plus 1. Now, after we factor by grouping, we should check for dots again, and this guy makes us think, but remember dots, the D stands for difference. We would need subtraction, which we do not have. So that means we're done factoring. In example D, we start first by looking for a GCF. Now, I have a negative in my very first term, so I want to for sure get rid of that. So I know I'm taking out a negative. Every number is divisible by 2, and I have at least one x in every term. So my GCF is a negative 2x, and that leaves me with, okay, negative 4 divided by negative 2 is a positive 2, and then we're left with x squared. Positive 10x squared divided by negative 2x is going to be a negative 5x, and those last terms are going to become a minus 12. Step 1, we took out a GCF. Step 2, we're looking for dots, but I don't have any. So I move on to step 3, which is trying to factor like normal. Now, because I couldn't get rid of everything in front of my x squared, I have to use divide and slide. That negative 2x is just along for the right out front. I still set up my parentheses the same, but before I think of those numbers, I multiply a and c. 2 times 12, I get 24. Numbers that multiply to 24 and subtract to 5, that's going to be 3 and 8. My signs are different. My bigger number is minus, so minus 8 plus 3. But we cannot forget to divide and slide. So we want to divide and slide by that 2, which was in front. That minus 2x out front, still along for the ride, not going anywhere. My first set of parentheses, I have to slide that 2, so I say 2x plus 3. But that second set of parentheses, 8 divided by 2, simplifies to 4. Now, after we factor like normal, we try grouping. Well, that wouldn't make sense. So then we say, well, maybe there's dots, but we don't have anything squared. So this is our final answer. In example E, we move on. Now we're already only starting with 2 terms. Remember, your only options if you have a binomial are GCF or dots, or maybe both. So we always look for a GCF first, and in this case, we can take a 2 out of both of our numbers and an h squared out of both of our variables. Because that first term had 4 h's to give, and that second term had 2 h's. So my 2h squared is along for the right out front now. 50 divided by 2 would give us 25. H to the 4th divided by h squared is going to give us h squared. Now in that second term, everything cancels out to a 1. And don't forget, we're subtracting in between. Now we took out our GCF, and look what we're left with. I can square root that first term, and I can square root that second term. We're subtracting in between, so that tells me we have dots. So we start with that 2h squared. Remember, dots becomes 2 sets of parentheses, 1 plus 1 minus. To find out what goes first, we square root our first term. The square root of 25h squared, well, square root of 25 is a 5. Square root of h squared is just h. And then to find out what goes last, we square root our last term. Well, that's just going to be 1 and 1. So now we're done factoring. In example F, we have 6x squared minus 21x minus 45. We, of course, start looking for a GCF. Something I can take out of all 3 terms would be a 3. So I set it aside to be left with 2x squared minus 7x minus 15. So I took out a GCF. I look for dots next, but that wouldn't make sense because I have 3 terms, so I'm going to factor like normal. Because I have something in front of my x squared in my parentheses, I use divide and slide. So I'll multiply 2 times 15 to get 30. numbers that multiply to 30 and subtract to 7 are going to be 3 and 10. So I have 3 out front. I have x and 3 and x and 10. My signs are different. My bigger number is negative, minus 10 plus 3. But I have to remember to divide inside by that 2. I bring the 3 way out front along for the ride. I have to slide in that first set of parentheses, 2x plus 3. And that second set of parentheses, I am able to divide and just get 5. So I have x minus 5. Now, just to be sure, I don't have any dots that this left me with, nor do I have any other GCFs, so I must be done. In example G, I'm able to take a 2 and a y out of everything. So I set it aside, and I'm left with a y squared minus 6y plus 9. Then from here, I say, okay, I took out a GCF. Next, I check for dots. Well, I've got 3 terms, so it can't be dots. So I factor like normal. So I have 2y, and I set up my parentheses. I'm looking for numbers that multiply to 9 and add to 6. Well, that has to be 3 and 3. My signs are the same. They are both minus. I don't have to divide inside. I don't have any dots left. I can't factor by grouping. So I could be done. There's one other way we could write this. That would be if I said y minus 3 quantity squared. But other than that, we're good to go. In example H, I have a GCF that I should look for first, always, always, always. And that's going to be just an m. And so I bring that out front. M cubed divided by m is going to be m squared. Minus 2m squared divided by m, I'm left with one of them. Minus 8m over m is just 8. I bring the m out front along for the ride, and I set up my parentheses. I have an m and an m. And I want numbers that multiply to 8 and subtract to 2. Well, that has to be 4 and 2, or 2 and 4. My signs are different. My bigger number is minus. Minus 4 plus 2. I didn't have to divide inside. I don't have any dots left over, so I'm good to go. Excuse me. Then in example I have 4 terms. So after I look for a GCF and I notice I don't have one, oopsies, and then that should be a 12x. That was my bad. So I look for a GCF and I don't have one. If I've got 4 terms, I have to factor by grouping. So I've got my first group and my second group. From my first group, I can take out an x squared. So I do, and I set it aside to be left with 3x plus 1. Now from my second group, in order to be left with a positive 3x plus 1, I need to take out a negative 4. Now my GCF from each group is that set of parentheses, that 3x plus 1. And that leaves me with an x squared minus 4. Now, this is when we said, hey, after you factor by grouping, watch out for dots. Because what do we have in that second set of parentheses? A difference of 2 squares. So remember, those become, 2 sets of parentheses. 1 plus 1 minus. We square root the first term to find out what goes first. And we square root the last term to find out what goes last. Don't forget about that 3x plus 1 that was out front, because it is along for the ride. There is our final answer. Now I'll leave you to do that very last one all on your own. Go ahead and write in your answer and choose that for the question. Your homework is going to be to work on that worksheet, and we're going to come together for a live Google Meet class.